In this question, it's tricky because there's lots of wording. You've been given a differential equation, and you've been given an initial condition. And this time you were asked to find the equation of a tangent line. It's even bolded, which of course the AP test wouldn't do, just to remind you that you're not finding a particular solution. You're looking for y minus y1 equals m times x minus x1. And so you need an x, which is 5 from our initial condition, and you need a y that is 4, and you also need a slope. But slope, by definition, is the derivative, and the derivative is dy dx. So we're really given our slope as 4 to the negative 3 x squared. Well, that same x is 5 applies. So we have 4 to the negative 3 times 5 squared. Well, that is 4 to the negative 3 times 25. And that's really 1 over 4 to the 75 because of that negative exponent. And that's my final answer. I can leave it like this, etc. Y minus 4 equals 1 over 4 to the 75 times x minus 5. That is a very legitimate equation of the tangent line. Now it says use it to approximate f of 0.1. So all that means is that I want an estimate when x is 5.1. So 5.1 will go in for x, and my estimate is y minus 4 equals 1 over 4 to the 75 times 5.1 minus 5, well, that's just really 0.1. And without a calculator, there's not much more I can do besides add 4 to both sides. My estimate of y is 1/10 0.1 divided by 4 to the 75th plus 4. The last part asks if your approximation is an overestimate or an underestimate. And the only way to figure that out is to go back to our concavity. We've got some line estimating some curve. We don't know if our curve is concave up, like the blue one, or concave down, like the red one. So if this is x equals 5, only the concavity, which is found with our second derivative, will tell us. So I need to take the second derivative. If my first derivative is 4 to the negative 3x squared, then I need to find the second derivative. Well, this is going to be a chain rule problem. I have an inner function of negative 3x, so it's really 4 to the u. So u prime will be negative 6x, and v prime will be ln of 4 times 4 to the inner function of u. And I'll multiply these two derivatives together. So my second derivative, f double prime, will equal negative 6x times ln of 4 times 4 to the negative 3x squared. We're looking at this when x is 5 or 5.1. It doesn't really matter. I'll just use 5 to make it simpler on the math. And all I'm looking for is, is my second derivative greater than 0 or less than 0? Greater than 0 would be concave up, the blue graph, less than 0 would be concave down. So 5 times 6 is 30, so I'm going to have negative 30 times ln of 4 times 4 to the negative 3 times 25. Well, all of this is positive. This negative value up here just puts everything into the denominator. So I have a really small value, but it's positive, times a negative number means we are less than 0. Our graph is concave down, just like it shows here in red. And so that means this value, this estimate we had at 5.1 is an overestimate from the actual graph that is concave down and therefore below it. So we would say we are an overestimate because the second derivative is less than 0.